like TV from other dimensions has a somewhat looser feel to it.
Yeah, it's got an almost improvisational tone.
Hey, maybe we got some people online, maybe we don't. I'll see. Does my Rick and Morty shirt show the background through it? I don't know. We're being green screened. If you're here right now, say anything in the chat. We can work on some problems, do some regression, do some data mining. If you're here, say hey. Currently in the chat. So we'll see if anyone shows up today. We've got randomness for 201 right now. Maybe talk a little bit about regression or something. But if you are here, say hey. We're going to hop over to the screen right here. Let's go to the full screen. Oh, it's the random. We're still playing the random from yesterday. Oh, no. Random is around still. Oh, my gosh. Well, randomness is everywhere. So, so let's take a look right here. We had the randomness button still playing from yesterday. Okay. So we are, I don't know, let's do, if you come in, say hey, and we'll just do some work right here. I might just broadcast for a little bit today. So we got test 1 done. We've got 474 is going to be working on their coding quiz or coding test, coding night. And other classes are doing regression. So when you think about regression, we could just look at some data right here. One of my favorite things is the data sets in reg class. Now, reg class is a package inside of R, so you need to make sure you have reg class, which you might. But reg class right here is the package. This will install it. I'm going to click no because I've already got it installed. So we're just going to forego that. And I'm going to hashtag that out. Now, when you hashtag something, that makes it a comment, as in it doesn't do anything. But it also read through to the next line of code, and you can see kind of the differences in the colors. It's important as you learn how to code to kind of see the differences between the colors, to where this right here is a string, this is just numbers, and this is an object right here, as we would handle these objects inside of R. So all this right here, let's remove it, and let's start doing a little bit of regression right here, just for fun, to keep our skills fresh in regression. Regression has so many cool things, so we need a data set. We're going to pull up data, survey 10. This was a survey done of students in 2010, completely anonymous, and probably the first thing we want to do is we want to look at it. Now, I'm going to show you one of my favorite packages right here, which I don't know if it's on this computer yet. Did I put dplyr on here? That's not how you spell dplyr. I did. Oh, there's dplyr. dplyr is a package by Hadley Wickham, and one of the really great package creators in R. Packages are just things that have a bunch of either functions in them or data files or things you can use. Just think of it as you get this package with all these really cool things in it. It's like it's Christmas, and so you get all these great things. So we're going to look at a function I really like called glimpse. So, and I want to point something out. When I start to type glimpse, you'll notice that it actually shows me right, let's point where it's at. Right here, you can see what package it's a part of. It's part of the dplyr package. So that's telling me that this glimpse function is part of the dplyr package. Now, this, you might not want to put this in your assignments because it can create longer output, but I'm going to do a glimpse of survey 10. It lets you glimpse at it, and what glimpse does, as opposed to structure, is glimpse prints to the screen all the things inside of a data frame or other objects and lets you look at them so you can see that this data frame has in it variables, 20 variables, 699 observations, and you can see things like gender, height, weight, all these good things right here. So it lets us see kind of what we're dealing with. So that's kind of a really great way to say, like, what am I handling? Let me glimpse at it. That's why it's called glimpse, just taking a quick look at it. You can see some of the observations, like the first person was left-handed. They are on Facebook for 60 minutes a day. They do 100 texts a day. They have a 3.7 GPA. All this stuff is first person. Hey, Adam, what's up? Hey, Adam, if you're working on a question, feel free to ask. I'm just doing some regression right now, just like regression. Any question you have, I can hop over to the randomness assignments if you want. Ask the question, you're here, you get your questions answered. So, but good to see you in the chat. They're just kind of showing if you think about this, what I'm showing right here for my 201 students, if they're looking at this, all I'm looking at is an Excel spreadsheet. It's just an Excel spreadsheet. Just think of it that way. And what we're going to do now is we're going to write a really quick regression. To write a regression, it's called a linear model, because in regression, we fit a line. That's what LM stands for, is linear model. So we're going to fit a line to explain height, and I didn't do the open parentheses. We're going to do height, tilde, weight, if I knew how to spell, comma, data equals. Now I like to say y tilde x comma data equals. I shout that out all the time. Y tilde x comma data equals. Why am I saying y tilde x comma data equals? Let's put a note in here so we know what we have. This is your y variable, this is your x variable, and this is your data frame. So y tilde x comma data equals. The y variable is what we want to explain, which will be on the y-axis. The x variable is what's doing the explaining, hence it's the x variable. And the data is the df. I call it df for data frame, so I'm just using abbreviations here. If I run this, it won't work. It won't work because there's no object in the environment called df. It says it can't find df because there is no data frame up here. If you look right above me, I can just point to it. That's the environment, and there is no df in the environment. df meaning data frame. This function works because it looks and it finds the survey 10 data frame. Survey 10 data frame, let's go find it. Let's show it. Hard to see your mouse on the screen sometimes. Here's the survey 10 data frame. You can see it. We'll make it bigger so you can see exactly what it says. It says survey 10 right there. It goes inside of the survey 10 data frame and it finds height and weight and uses these variables inside the data frame. So all I'm saying is use height to explain weight and use the data frame survey 10. Now what's really great about this is you can go right here and you can just do a summary of your regression model. And what people in 201 might realize is we saw this with jump. Jump actually gives you all the same things right here. Let's talk over a tiny bit what this output is and let's explain it. So here's all the output we got. We're just going to expand it so we can see everything. And remember, if you're in 201, you can be like, hey, Brian, do this randomness problem. I'm just talking a little bit about how to interpret some regression. If I had a question about what I got wrong on the project, is there any way I could see that because I got it? Yes, go to the comments and check it out and tell me what you got wrong, and I'll make sure I agree or disagree with it. But you should be able to go to, and if you can't find it, come swing by or email me and say, hey, Brian, can you show me where it's at? But there should be a button to look at it, and the graders I've looked, and every project I've looked at has had the comments for why points are off. And great job. That's a great grade. So feel free to definitely, if you can't find it, ask and email me, and I'll make sure we see why. And I'll see if I agree or disagree. Sometimes I disagree, and I give the points back. But great job. So what do we have in this output right here? We have right here, and feel free to ask any question. Like you are the person here, Adam, so you get to ask all your questions. I don't know if anyone else is here. But the very top of this is the residuals. It might make more sense to look at the residuals if we visualize the model. So there's the visualization of the model. Let's take a look at it. I'm going to make it bigger so we can see the visualization of the model and maybe look at the residuals. To make it visualize properly, I'm going to have to expand the window. It's going to look crazy for a second. I'm going to re-visualize the model, and here we are. So here's the visualization. Your comment just is great. Send me an email. I'll make sure I'll find out. And if there's no points, if I don't see anything with points off, you get the point back. So you did do a great job, though. I think you might be reading the overall comments. There should be like comments written annotated on the report. And you know what's funny? Cracking me up. If you notice, you can actually see the residual down here. This is the super negative. It's right next to my head. This point right here is the most negative residual. You can just barely see it in the plot. There's a point way over here, which is the most positive residual. And I'm going to have to make this plot a lot smaller, and it's going to get scrunched up again, and the graphic's going to look weird. But you see here this negative 21. What does this negative 21 represent? And we have positive 13. Okay, let's bring this back. Let's take a screenshot of it and talk about this and talk about what a residual is. Because we have to know what we're seeing when we see this output. We can't just look at output and be like, oh, that's cool. We have to be like, what does this mean? What does a residual mean? Well, we're going to go here to a new sheet, and we're going to talk about what the residual means. When we talk about a residual is how much the model misses by. So I think negative 21 was the most negative residual, and we can kind of tell where that's at because the most negative residual, we're going space pen, looks to be this right here. That is a distance of negative 21 below the line. So that is negative 21 below the line. And it looks to be about that because look, if you were to trace over to where this hits, this line, the red line's the prediction line, and it's about at 75, and then this is about at 54. So that's a difference of negative 21. Yeah, no. And no, if you can't, we can't tell why, you're getting that point back. If we can't tell why, you are getting that point back. So I think the most positive residual, sometimes the little things can block it. That's why you can actually move this right here. There's loc in the there's a thing called loc, which if you do loc equals top right or loc equals bottom right or loc equals center, you can move the thing I'm showing you. That's the location of the legend. So I think the most positive residual is this one right here. And if you look, the line hits at about what is that, about 62? And then this point is about at 75, so that makes this residual about 13. So these are if you took all the residuals and looked at their values, the most positive looks to be about 13, and the most negative looks to be about negative 21. Let's go back to R. Let's decrease the size of this window, and look right here. Boom. That one was the most positive over there next to my head right there. That is the most positive with a residual of 13, and this is the most negative with a residual about negative 21. Once again, just to make sure you understand what we're talking about, I'm talking about these 2 points. This point right here has a residual of negative 21. I've identified it. I've calculated it kind of with my eyes. And then also right here we see a residual of positive 13. That means that that point was 13 above the prediction line. Negative 21 means that this point is 21 below the prediction line. So we understand what's going on right there with the residuals. Residuals should be generally centered at 0 because the line is going through the middle of them. So we would expect a median close to 0. We do see that there's an extreme outlier. That's what I would identify here. We've got a very negative extreme residual as shown by our plot. Once again, what point are we talking about? I'm going to make this super clear. If I am drawing this, I would put a huge highlight over that, and I'd be like, that is a huge outlier. That is the biggest residual, the most negative, and this is the most positive. But the most negative is even more extreme because it's negative 21 as opposed to positive 13. And we'll do more on residuals later on, or you'll learn more about residuals as the class goes on with standardizing them with t-scores and stuff like that. So for now, we just get the actual values of the residuals, which is how much we miss with our predictions by. So now we're going to get into the output here, but we need to know what each of these mean. We have estimate, we have standard error, we have t-value, we have p-value, and we have intercept, and we have weight. Okay. Let's talk about the estimate. When it comes to the estimate, these are the estimates of B0 and B1. These are the estimates of B0 and B1. So let's grab this output. Let's bring it over here. New worksheet. So the estimates right here that we're talking about, this is literally B0, and this is literally B1. Those are B0, those are B1. Afterwards, could you, yeah. Is that the one, which one is that again, Adam? Is that the one I did the long one? I'll do it again. I'll do it again today. And I'll mention what this output is real quick here, and then we'll hop back over. So with this right here, the estimate of B0 and B1 birth defect problem. Yeah, let's do that one. That one's a fun one. So they're all fun randomness problems. I got the randomness button still here today. So, I can click it. I won't click it. So what we have right here is B0 and B1. Now, how do we use B0 and B1? Stat1 should know this. We use B0 plus B1x. This is the name of the x variable right here. Now, these are the standard error of B1, or B0, excuse me, and this is the standard error of B1. That's the t-score right there, and we'll talk about how to get this. All of these t-scores, every single t-score is calculated by doing your estimate over your standard error. Now you have to take the right estimate. So literally you can just take and divide these two numbers, as in 56 divided by 0.58. That's like 56 divided by 0.56, which is like 100. And then you've got 7 divided by 0.0035, and if you just change the decimals around, you can see it's about 20. Let me show you by just doing the math right here that 56.34 divided by 0.589459. I'm dividing the estimate by the standard error, and we get the t ratio. Now, I didn't carry all the decimals, but you will get the t ratio. Chapter 10 is coming up, and I actually did that homework and quiz week 1, so I'm so glad you did that. That's awesome. And then the p-value, so we'll finish this up here, and we'll hop over to 201. The p-value right here is the probability of our results. Our results are more extreme, happening by random chance variation, given that the null is true. But the only one we really care about is the p-value for weight. Because what does weight control? It is connected to the slope, and the slope is the xy relationship to the line. So we want to say that we have evidence the slope is not 0, and that's what we're seeing right here. This is evidence that the slope is not 0 because we have such an extreme t-score. And we could go more into this and this output. Understanding where these numbers come from is very important. this p-value actually comes from plotting the t-statistic, and we're at 20. T-scores are basically like z-scores, so I purposely left enough room to be at 20, which is off the chart. And then we plot one just as extreme because we're doing the probability of our result or a result just as extreme, and then we get the area outside of this. Adam, for 20,000 points. How much area looks to be on outside of this curve right now? So here's the inside. How much looks to be outside? Basically, what looks to be outside this curve right now for 20,000 points? I'll give it to you even if you get it wrong. How much area looks to be outside this curve? This is the last question I'm asking. How much area looks to be outside that curve for a t-score of 20, which is kind of like a z-score of 20, which is crazy. Julio gets it right there. Julio just jumped in and got those. I'm giving it to both of you. So it's 0. And that's why the p-value is 0, because this t-score right here is so extreme that it's unlikely by random chance. Do you guys know what t-score would be likely by random chance? The t-score that would be likely, you both got it. I'm giving you both. So the t-score that would be likely by random chance is a t-score close to what? Now, this is going beyond 201 for a moment, and then we're going to do the 201 problem here. A t-score that would be likely by random chance is a t-score very close to what? A t-score that would be likely by random chance is a t-score very... No, you're fine. It was lots of fun. That was like fun right there. A t-score that would be likely by random chance is a t-score very close to what? Need shade all sides right here. 0. 0 is a t-score that would be likely by random chance. No, you both got it. Adam, I'm giving it to both of you. I thought that was so much fun right there. I don't know how many people are watching as we do the problems right here. So we got 4 people watching. I'll take it. 4 is great. One of them might be me. We got 3 people watching. So, and if anyone's in the chat, you can ask questions. We're going to do the My Pearson problem. And they come up with such great ideas for homes. So let's go ahead here. We're going to do the My Pearson problem. I'm getting it pulled up as we speak. So if you have a question in the chat, feel free to put it. And so glad to have everyone. We just like to do as much work as we can. I hold these online office hours just to help out since people can watch these later. Good way to just learn how to solve certain questions and get practice. And I can't see the chat right now, so I'll be looking at the chat here in a moment. For some reason, I have to reload my Pearson every time. Okay, we're going to go to assignments. We are just moments away from doing the homework question. Preview. Let's go to replace question. And here we go. Okay. Here's the question right here. Let's bring up the chat again. Chat is up. And here we are. Let's bring up the screen. Cool. Okay. So when we look at this problem right here, what we're doing in this problem, always try to think of these questions as trying to simulate reality. We're looking at the probability that a baby is born with a birth defect. And to do this, we are going to use random numbers. Now, the problem tells us that 300 babies are born and 21 would be born with birth defects. So that's 21 out of 300. The first thing we want to do is figure out what the probability of this is. We got some numbers previously in the calculator. Let's type 21 divided by 300. This is telling us that the probability is 7%. Now, there's different ways this problem is written. Sometimes it's out of 100 or 400 or 500. But we need to remember 21 out of 300 is how we're calculating the probability, which is 7%. Now, I've had people say to me, why can't I just use 10 numbers? Well, if it was 70%, we could use 10 numbers, or 10%, or if we got a question that said 7 out of 100, well, that would be 7% also. Now, this is where it gets really confusing for most people. It makes sense that if we have a 7% probability that we could use 100 numbers. Now, in truth, you could set up the problem this way. You could set up the problem to do a simulation where 1 through 7 is birth defect, and 8 through 100 is not. So we'll put yes, and we'll put no. That's a fine way to set up the problem. But what we do in statistics a lot of times is we like to use 2-digit number combinations. And there's one number on here that's not 2 digits, and that's 100. Even 1 can be described as 2 digits, as 0, 1. So how about we do this? We're going to take the 100 and move it to the other side, as though we're doing 1 through 100, but we take that 100 and put it down here, and we just take off the 1 off it. So now we've got 0, 0 through 99. So the first number is 0, 0. We've just moved the 100 to the other side. And so now let's take a look at this. Now we're going to go 0, 0, which is a 2-digit number combination. And we need to move everything to the left just 1 through 0, 6. And then we have here 0, 7 through 99. If you notice, we've just shifted it over the tiniest of bits. Does that make sense right there? Because just count for a moment. 7 numbers, 1, 2, 3, 4, 5, 6, 7. Now count starting with 0. 0, 1, 2, 3, 4, 5, 6. If you count starting at 0, you get one extra number because of 0. So 0 through 6 is 7 numbers. Because 1 through 7, 7 numbers, and then you just shift it this way, just the tiniest of bits. So if you notice, everything looks the same. It's still the same numbers, and we've achieved our answer right here. Our answer has now been achieved because we have 7 numbers right here. Let's make it very clear. In both of these numbering schemes, there's a 7% probability here and a 93% probability here. And why do we want this? We want this because this is the way the simulation is set up. The simulation is set up such that we need to use all the numbers from 0, 0 to 99, and we're going to skip none of the numbers. So use 2-digit number combinations. 0, 0 through 0, 6 represents babies born with birth defect. 0, 7 through 99 represents not born, and that should do it. Did that help out right there? So what was the main reason behind using 2 digits? You could, the reason behind 2 digits is because, think about this. If you use 1-digit numbering schemes, like if you only use 0 through 9, let's like use numbers 0 through 9. So if you use the numbers 0 through 9, if I call this yes and I call this no, what is the probability of yes right now? If I call those 2 numbers yes and the other 3 numbers no, or the other 8 numbers no. So if I call those 2 numbers yes and the other 8 numbers no, what is the probability of yes right now if I do a simulation? If I do a trial in simulations, then what would be the probability of yes? If I just start picking numbers, I'm like, let's generate random numbers to see what happens. And I say, if you get 0 or 1, you pass the class. If you get 2 through 9, you don't pass the class. And this is using 1-digit number combinations, which is 10 numbers. 20% exactly. Can you figure out a way to use a certain amount of numbers where it's 7%? Exactly. Great answers in the chat. 10,000 points. Love it when you guys are here for this. Can you figure out a way to make it 7%? Not 70%, but 7%. Is there any way I could pick a certain amount of numbers? Well, let's try to pick the fewest amount of numbers for yes. If I pick just this number here, it doesn't matter which number I pick, but we'll just pick it because it's closest. And then I have this be yes and this be no. What percent of the time does yes occur by random chance just using simulation? It would occur what? It would occur 10%. So is there any way for me to use 10 numbers and to do random probabilities of 7%? Can I do 10 numbers and get probabilities of 7%, just pulling random numbers and get a 7% probability? Every probability I get would be either 0%, 10%, 20%, 30%, 40, 50, 60, 70, 80, 90, or 100 because it's all tenths exactly. 1/10, exactly 10,000 points. 1/10, you can't make it equal to 0.07. But meanwhile, when you use 100 numbers, you're going up in increments of 0.01. So you can simulate using 100 numbers because you could say like, okay, 7 out of the 100 numbers mean this. But with 10 numbers, you can only do it in increments of tenths. That's exactly. Does that make more sense, Adam, right there? We have to use 100 numbers because we want 7%, and we can only achieve that by using 100 numbers, which allow us to do it by 1% differences. I hope that helps make sense right here because 10 numbers can't achieve the goal. Yes! That's awesome, Adam. Great questions. I'm glad. And whenever people think it doesn't make sense, just tell me, like, I still don't get it. One time I remember I explained something like 5 times. The student was like, I still don't get it. And I was like, I'm gonna make it. You got it. I'm gonna help you understand this. So I'm glad that, yep. What other questions does everyone have? It might be a short day, but ask those questions. Be like, hey, Brian, work this problem. Hey, Brian, explain this. Any concepts you want me to review over, happy to go over. Whatever class you're in, as long as I know it. Be like, Brian, do my partial differential equation. I'd say, no, I can't do that. It's man on the street. Didn't even cross my mind that you'd run into that problem. Yeah, no, it's just you just have to, don't worry, it's a great question because you have to think, why does this not work? And it's like, because we don't have enough numbers to make it work. and that's a great question. It's like, why doesn't this work? Adam, I'm throwing you 10,000 for asking it because I want people to be like, why doesn't this work? Why is an amazing question, which I think you were asking. Like, you're like, so what is the reason for this? And that's a great thing to ask. Like, what's the point of this? Why do we do this? And I want more people to ask that. I've still got the block up from Kahoot. If you notice that little gray thing on the screen, I'm gonna remove it. Oh, it's gone. Look at that. That was from the Kahoot when I was blocking the code. So what other questions are there today? If you're in the chat and you have a question, hey, Brian, work this problem. Hey, Brian, explain this. What is this concept? What is clustering? What's the coding exam going to look like? I can't show it, but I think a lot of people know we talked about it in class. Let's see. Let's look at, we're almost done with the R output right here. So if you notice right here, we have an intercept, and we did this in 201. But, yeah, I was shocked about that. Thank you for that, when you showed me how to do that. I really didn't realize you could do that, and it's a much easier way, and I wish they'd just fix it, but I might even do that in my video. I'm going to try to do it on a Mac and a PC, and I might make a more advanced version of it, and we've got a lot of time. It's not due till like next Tuesday, so I had never seen that, and that's a much easier way than saying, it double copies it. Remember to delete the duplicates. You do something for 10 years and then, you guys teach me things all the time. You'd be surprised at how many things I say or teach you guys that students have been like, actually, I learned it this way, or, like, this is a better way. So I'm really glad that you guys do that. You have I agree. I might get it done this weekend or something. I've got another task this week. I've got a Shiny app to make. I give myself work. It's fun. So no, that's awesome. I agree. No, and I appreciate you making the video and showing me how to do it, because if you know a better way to do things, I'm always up for that. I'm that type of person. If you're like, hey, this works better, I'm like, oh, tell me, how'd you do it? So we have here, and I will give you credit, Adam. I'll be like, Adam showed me this cool new way to do it, and so I should make a video on it. I'm just gonna make sure it works on, because you did it on, I think you did it on Mac, right? I can't remember if you did it on Mac or PC. I watched the video, and oh yeah, the Mark Rober video with the impossible meat, that was awesome. I really want to try. He had like a sausage or something, and it sounded good. You did it on Mac. Yeah, I'm gonna make sure it works on PC also. I'm gonna like confirm both ways, and hopefully both ways. I'm gonna drop my pen. Hopefully both ways are similar enough. But yeah, the Mark Rober on the impossible meat was a really good video, and it definitely makes me. One, I'm really glad he showed that veggie burger at the start. He's like, this is what I used to think it was, and then he shows the impossible meat. Have you had impossible meat, Adam? This is just chill now for the moment. I don't think I've had any impossible meat. I should just go to Burger King and order the impossible burger and just see what I think of it. Difference between cluster and strata. Great question. Let's hop here. We'll see what. Julio, have you had impossible burger or anything like that? The plant-based meat substitutes? We got a blank document right now. And we'll talk about cluster versus strata right here. So when we talk about cluster versus strata, and this is something we'll be doing next class, because this is a big concept people get confused. So we will do that. So when we do this right here, we have strata and we have cluster. Okay, so we have to keep these two straight. This is where people just lose points on the test, because what do these both seem like? In both of these, there's groups. So that's the similarity between them. But take this note. I know, I want to try it too. We should go get Impossible Burger tonight. So with these right here, here's what I want you to write down if you're writing down and taking notes. Strata. In strata, we acknowledge differences. In strata, I imagine they're good too. In strata, we acknowledge differences. Strata, acknowledge your differences. Clusters, take a whole bunch at once. The goal of clustering is to take a whole bunch of like-minded things together. The goal of strata is to acknowledge differences. Oh, so Braden, awesome. So good to see you. Yeah, we're glad to have you. We're doing some next class stuff right here, Braden. So good to see you. Thank you. Enjoy the jazz class. So I just love people popping in like that. It's so cool. So strata, acknowledge differences. Cluster, take a whole bunch at once. So here, ready for some example questions? Adam, we'll be doing this very soon, so get ready. This is practice. Let's say Brian were to go to a table of students and take the whole table of students as a sample. Now, there's something I didn't tell you about cluster. We're just kind of doing this at a very surface level right now. Kind of give away the answer right there. But if Brian took a whole table of students, would that sound like strata, where we acknowledge differences between the groups we're taking, or cluster, where we take a whole bunch at once? A table of students is probably a decent example of a what? Cluster, yeah. Because in a cluster, it's not convenience sampling, but which we'll talk about that more next time. But it's an easier way to get data to say, let's go to like a good way to cluster, and Julio and I were talking about this, like a team might not be a good cluster, but maybe if you went, it's so hard because you have to make sure all the clusters don't have differences between them. The best way to talk about it is like a bag of M&Ms. A bag of M&Ms is a cluster of M&Ms. A 6-pack of Coca-Cola is a cluster of Coca-Cola. A 12-pack of donuts or 12 box of donuts is a cluster of donuts. Do you see? All I'm saying is 12 donuts, 6 cans of Coke, a bunch of M&Ms in a bag. That's just a cluster. Does that make sense? That's just a bunch of them. But let's now hear the difference with strata, and I'll do some really in-depth definitions on this during class. Strata is when you acknowledge differences and then sample in accordance to those differences. So if I say peanut butter M&Ms, does that mean I'm going to sample like a percentage of the peanut butter and M&Ms, or take all the peanut butter M&Ms? I'd love to take all of them, but what do you think? I'm giving huge hints today. If I say we're going to do strata based on type of M&M, what I'm saying is we're going to sample a certain amount of peanut and a certain amount of regular M&Ms. We're not going to take all the peanut and all the regular, because that's what cluster means. So strata is kind of like a subgroup for sampling. That's pretty much what it is. And why do we subgroup? Imagine this is a really good example here. When we stratify, we might have athlete. So we have athlete and we have non-athlete. So why would we stratify in our sample on athlete and non-athlete? Let's say we ask people, should we build a new training facility? Should we spend $20 million on a new training facility? And some people might say yes. But who do you think might be more inclined to say? And I mean, as long as I get to work there, I don't know. I probably wouldn't use it. I'd be like, I'll go work out every day, and then I wouldn't do it. But who do you think would be more inclined to? Yeah, exactly. So, and when we stratify, if like 10% of the UT population is athletes and 90% is non-athletes, then when we stratify, they'll say yes. They'll be like, oh yes. So the problem, what we do in strata is we say, okay, our sample is going to be 10% athletes, 90% non-athletes. And cluster just means to take a whole bunch. So if you could literally take a cluster of students, and what you could do is you could go to tables of students. Now you have to watch out because these are all groups. But the goal of a cluster is that a table of students is just a table of students. Is there any reason that table A versus table B should care about the differences between whether we should have a new workout facility, new training facility? Should table A versus table B have any difference in views with the clusters? The clusters are meant to be virtually identical, as in, we take a cluster, a table here, a table here. It's just easier to go out and take the tables. So when you take a cluster, you're taking a whole bunch at once. And here's the last thing I should say on it. You're doing a census of the cluster. So when I walk up to that table of 8 students, how many samples do I get with a table of 8 students? When I walk up to a table of 8 students, how many samples do I get? Because you go up to a randomized group is a cluster, just random group is a cluster. You get all 8 of them. Now, when you do strata, you're going to say, hey, Jeff, good to see you here. And you're going to get the whole table. So when you do strata, you want to say, I think these people hold different views. Imagine if we wanted to see, here's a pretty decent one. I like to do election stuff. People know about election stuff. If you're looking for how the election is going to go, what might be a strata for when people vote? What would be a strata for people voting? Will be a good idea of a strata. You have to acknowledge a difference and say, we want to make sure we sample the percentages, like don't sample too much of this or too little of this. So I'd have to put a lot here, but what might be stratas for election? Actually, you can name a lot of them. What might be different strata, how we'd stratify when taking samples for elections? There's a lot of answers there. I've already got 2 in my head. I've got 3 in my head now. So who's got an answer for how we might stratify when it comes to elections? And this is where you acknowledge a difference and you say we want to sample and take representative amounts of each group. Political party, boom, 10,000 points right there. So party, because what if I only talk to Democrats, Republicans, or independents? If I only talk to like Democrats, you'd say that's not a good representative sample. Only talk to Republicans, not representative. So party, we would stratify on party. Stratify means we're going to make sure that we take a certain amount of each party. Age group, there you go, perfect. Because you're going to say, I'm going to take and think about, if you were to say cluster, this is where it sounds weird. If you take a cluster of age group, that means you'd go to like the 20 to 30 year olds and you'd say, we're taking all the 20 to 30 year olds. And that is not representative. So when you say you cluster an age group, no, that'd be taking a whole age group. And that's not representative. You stratify, which means you look at the age groups and you say, okay, 18% of people are 20 and under who vote. 30% are between 20 to 35. I'm making up fake numbers. But then you sample the percentages, and according to that, you make it look like that. You might say 40% of people are Republican, 40% are Democrat, 20% are independent. So we make our sample look like that. If you were to say cluster, someone say in the chat, and you'll know what I'm talking about. If we pretended that we took a cluster of party, what would you be doing? And you'd be doing it incorrect. You'd be doing it wrong. If we took a cluster of party, what would that mean? And it'd be wrong. If you took a cluster based on party, what would that mean? A cluster based on political party, this would be wrong. What would you be doing? Like to do that, you would have to do this, and it would be a bad idea. To take a cluster on political party, you'd have to do what? Think of what it means. You were saying it earlier, if you were saying in the chat. A cluster on political party is a bad idea, not representative, because you'd have to do what? You'd have to take what of a political party? Take everybody on that political party. Yep. And that would not be representative. A cluster of political parties is like taking all Democrats or taking all Republicans. And they're not randomly in those groups. Those are differences. So you say you stratify on it, which means you take from each group according to the amounts that are in each group. So when we get our sample, we make sure we have like 40% Republicans, 40% Democrats, and 20% independents. I'm picking those numbers pretending that that is what the distribution of people's affiliations are. But maybe you're in like Texas and it's like 60% Republican, 30% Democrat, and 10% independent. Or you're in California and it's like 6% Democrat. So you would take the percentages according to the population. So if you sampled 100 people, then you'd have 60 Democrats in California, 30 Republicans, and 10 independents. And that would be representative because you're stratifying on it. And so the last one, what was it? Oh, state. Because you notice I was just mentioning state, but you could stratify on state. So if you want to see who's going to win the presidential election, you don't just want to talk to people in, let's say, Tennessee, because if you talk to people in Tennessee, you're probably going to see a more conservative person winning, where if you talk to people in California, you're going to see a more liberal person winning. So you want to take representative amounts from each state. But what if we said we're going to cluster on state, which is not what we would do? What would we do if we said, let's do a cluster now, let's do a cluster sampling where we take a state as a cluster? Taking a state as a cluster would mean doing what, which we don't want to do. It would not be representative then. To do doing clusters with states would do what? So if someone said, let's do a sample where we take states as clusters. What would that mean? That would mean we would take, someone's going to say it in the chat. If you're watching the video, think about it, write it down. Clustering on state would mean that you would take all of a state. You would take you would go to like Tennessee and be like, we're going to take all of one state and that's going to be our sample. That's a horrible idea. That state is not representative. But stratifying on state says, okay, we need 3% of our samples from Tennessee, 5% from California, 1% from Nevada. Like you do it by the size of the state and the percent that vote they have, or maybe on their electoral college size. But you do it as a percentage of what they contribute. So states that have more votes would see a larger representation in the strata. Strata acknowledges differences where clusters, probably my best examples of clusters, is where everything is pretty much the same between clusters. Like if I say a bag of M&Ms, is there really, I can't do an ampersand. Is there really any differences between bag 1 of M&Ms and bag 2 of M&Ms? Or packs of Coca-Cola? Packs of Coca-Cola. Is there really any differences between the packs of Coca-Colas? Boxes of donuts. I've got box of donuts A and box of donuts B. Now, if you notice, I'm not saying like sprinkled donuts versus glazed donuts, because those are differences. That would be stratifying them if I start talking about differences. But it's just like I have box 1, I have box 2, and you might say, well, it's box 1, box 2, but it's just a box of donuts. All boxes of donuts are equal, exactly. But you could, how would we stratify donuts? I already gave one example, but how could we stratify donuts? What's a way to stratify donuts to acknowledge a difference, to say, well, if we're looking at how our donut factory is doing, we should maybe take a certain amount of these donuts and a certain amount of these donuts because they're different. There's many ways. And I heard a really good place that Chelsea and I like, Maker's Donuts. I heard that might be reopening. Donut hole versus normal donut. Yeah, exactly. Imagine if we had people taste testing our donuts to see if they like them. So if we only took the donut holes or only the donuts, well, we want it to be representative of what we make. We want to know what do people think of our product. So if we sell, tell me this, Adam, if we sold 70% donuts and 30% donut holes and we have 200 samples given out, how many should be? So I'm going to write the numbers on here. We sell 70% donuts and 30% donut holes. And we have a sample size of 200 that we're going to put on a platter and ask people to review. So how many donuts will be on there for people to try? How many donuts will be on there for people to try? So when we do this to see if people like what we're making at our factory, how many donuts will be on the samples we're giving out? How many samples of donuts will we put on there to be representative of what we're doing and to see what our customers really think? How many donuts will be on there? And this is the idea of strata. There'll be 200 total items, but the donuts are 70% of our sales. Hint, hint, hint. So out of the 200, to be representative, how many donuts should we have people sampling to see, do people really like our business? What do they think of our products? On the sampling that we put out there, we should have how many donuts are being sampled. So we give someone we're just like, oh, hey, would you like to try a sample? 140, you're right. Because that would be, that'd be representative because we'd have them sample 140. So this would be 140. I got enough room back here. This would be 140 donuts, and this would be 60 donut holes. And so that would be representative of what we sell. That's the idea of strata. So we want people to, we want to put the right amount of samples out there to be like, okay, our business sells this. Let's see what people think of our products. Let's put a representative sample. Now, someone might say, but some of our donuts are baked and some of our donuts are fried. Then we'd have to do another strata. We'd have to have more separation. So every time you talk about strata, you have to acknowledge differences. Well, some are fruit flavored and some are savory flavor, like chocolate, or maybe you have a chocolate bacon. Some are breakfast donuts. We're like, okay, now we got to have representation of these donuts here. Because what is the goal when we do sampling? To get representative samples. So if you're thinking about this, you might want, with these 200, you're going to make a lot of different strata probably. If you're doing this as a business, you're going to say, okay, we need representation from the morning donuts. We need the sweet donuts. We need the fruit donuts. We need the donut holes. We've also got different types of donut holes. So let's make sure it looks like our sales. If you have an item that you only sell once every year, you probably wouldn't put it in this because it's not a good portion of your sales. So you'd want this to represent your sales properly. So it would represent what people are trying when they're rating your business is going to represent your sales, and you're stratifying by acknowledging the differences. So what you could do, you could actually get people to rate your business using this stratified method and then give people. So what if we went to each customer? This is getting interesting now. Each customer gets a platter of your items. So they get this platter. Oh, man, this sounds like I just want donuts. So they get a platter of your items. And so this platter is now a what of your items. That platter, which you chose what's on that platter via stratification by saying we need items that represent our business. Here's the differences between our business. And then the customer is going to give you ratings on all those items. The customer is now the what? The customer is going to give you these 8 ratings. And the customer is now the what? This got complex, but kind of cool complex. I like it. The customer is now I want to see the chat. Do you guys like it? It is now the customer is now the cluster. The customer is now the cluster. Because the customer is giving you 8 ratings. Can you imagine this long, you go to those really nice restaurants, they give you this long sampling thing. It's got these different things on here. So I've got a sampling plate. It's going to look huge. Here's our gentleman standing at the sampling plate. He gets to eat off that sampling plate right there. They're humongous donuts. It's going to be too much donuts. But the customer is now the cluster. Reason being is if I say customer A versus customer B, am I acknowledging any differences when I say customer A versus customer B? Like we're gonna have 50 customers give ratings to these 8 different donuts, which represent via stratification the differences between our donuts. The plate is, I know, that's quite the plate right there. It's like man versus food. We got Adam Richman right here. So, oh wait, is it the same name? Is that the same name? It is, isn't it? Whoa. Now Adam Richman's calling me. So right here, is that his name on Man versus Food? Oh yeah, it is. It's said the same way. Yeah. Wow, that was just like my brain just thought of that, and I was like, wait a minute. So this right here, what do we see? We see that the stratification right here is on creating what represents in the samples. But each plate right there, you're not the first one. Each of these humongous plates right here are a cluster. Does that make sense why customer A versus customer B, and I know it's one customer, but how many ratings is each customer giving us? From this plate, humongous plate of donuts, this customer is going to give us 8 ratings. So the customer is giving us 8 ratings, so the customer is giving us a cluster of ratings. They're going to rate each of the 8 items, but is there any reason, and don't think about who the customers are. They're customer 1, they're customer 2, they're customer 3, they're customer 4. Can you tell me any reason now that customer 1 will be different from customer 2 with only the information that they're customer 1 and customer 2? I can't. I mean, they might have different tastes, but that's just variation in sampling. And so, but when you think about donuts versus donut holes, obviously we know people have preferences towards those. People might be like, oh, I like donuts better than donut holes, and I like glazed versus this. So it's a really this versus this. But if you're just doing like cluster 1 versus cluster 2, that's what each customer is. They're just a cluster of ratings. Julio, does that help out a good bit? This is probably the hardest concept in this chapter we're going to do next time. So, this is a big one. I really like this example. I know last semester my brain broke on it. It was fun. It was like I hadn't eaten lunch that day, and I was like, what is it going to do? Of course, yes. And just remember that clusters are taking a whole bunch at once, like a bag of M&Ms. But how can we stratify? Nice. How can we stratify M&Ms? We have to acknowledge a difference, so you have to be like this versus this. How would we stratify M&Ms? How could you stratify M&Ms? I'll do this in class tomorrow. Adam, be quick. You might get some M&Ms from this. How could we stratify M&Ms? Any ideas on stratifying M&Ms? What would be a way to stratify them? Colors. Yes, those are differences between the M&Ms, especially if we're looking at defects in our factory. We'd look and say, okay, this is this color, it's this color. Adam, do you have a favorite kind of M&Ms? Even though exactly. Probably in the factory, we might look at to see if the food color is adhering to them properly. So we might look at the quality by color. So we might, in the factory, inspect our M&Ms. You're right. Thank you, Gabe. You're awesome. Yep. We're here to help. We're here to explain concepts, and that's what we do. We do statistics. If you have questions, feel free to ask. And so I enjoy any type of... You don't have a favorite? Because what about peanut butter M&Ms? Those are awesome. I mean, they're all good. I think I had coconut M&Ms one time. They were not that great. One M&Ms I didn't like. Candy corn M&Ms. Those exist, and I like those. But a lot of people don't like candy corn. So you're noticing now I'm mentioning different types of M&Ms. Are types of M&Ms like candy corn versus pretzel, are those different strata or clusters? Would pretzel and candy corn versus pretzel, would that be strata or clusters? So think of this. Would that be strata or clusters? Which one would it be? Who knows? Strata, you're right. It is strata. Because when it's strata, that means you're going to sample accordingly from within those. But if we said cluster, that would mean you'd literally sample all the candy corn M&Ms or all the pretzel M&Ms. And so when you take a cluster, you take all of them. Like this gentleman down there is going to eat all 8 of those donuts, or this lady down here, all 8 of those donuts, and tell us what they think. So they're doing a cluster, but then how did we pick what went into those clusters? We stratified. We did a really complex example a moment ago. I'm at Costco family. Sorry. Oh, that's totally awesome. Hey, family right there. Costco's so awesome. So I've like been there like once or twice, and it's like, I don't know. It's so like my mom has a membership to it. It's like really nice. I don't know. You just get a bunch of stuff at a really good price. It's like awesome. I like that right there. Pick up some M&Ms. It's good stuff. Well, that's got some clustering versus stride. Don't worry if you're not replying in the chat. It's totally fine. Family time is family time, and we're just here to help out. So hey, little ones. Hey, Julio's little ones. And awesome. Other questions right now, feel free to ask in the chat. I might go and reply some emails, and thank you so much. I like Gabe being in here. Like, I like it. Gabe's like, keep it up. Stay alive. And Adam, I'm glad that, people from every class kind of come in here, say, hey, what are we going over tomorrow in class? You're looking at it. So you'll be able to throw out those answers tomorrow. I'll throw out some points. I'll be like 1,000 points here. I'll throw out some 10,000, who knows. And I'll also bring some M&Ms to class. This is the lecture for tomorrow, which is going to be based on sampling. You'll need to know key terms. Hey, 3-year-old. Hey. You need to know key terms like sample, population. I'll write them down right here. Why not? Write them down in my bad handwriting. The key terms you will need to know tomorrow are going to be sample. Along with sample goes statistic. You need to know population. That's not how you spell population. You need to know parameter. I think that's how it's spelled. Parameter and, you're fine. However people learn, how they learn. You need to know sample frame. Sample frame. Come say hey, that's awesome. Sample frame, you need to know, we'll change colors now. We'll go to green. Green's just looking nicer. Okay, we'll do that. You need to know convenience. I think it's how it's spelled. Convenience, simple, random, systematic, cluster, stratified, and multi-stage. We're not done yet. We're close. And then you also need to know the biases. So you need to know the word bias. And we have here non-response. Response. Voluntary. It's voluntary response bias, right? It's convenience, response, non-response. Oh, and undercoverage. There we go. I'm running out of room. And I guess also convenience. Convenience can be seen as a bias too. Sorry, my handwriting's so horrible. So systematic is like every 34th. Yep. So it goes right there. You were talking about the neural networks the other day and caught my attention. Have you ever heard of the guy you named? Yeah, isn't he in one of he's in one of Mark Rober's videos, and he actually codes it in Python. If you look at his screen, he's doing some Python coding. They do the baseball stealing one, I think. And maybe he does. Hey, he does the baseball stealing one, right? If you have videos of his, send me his channel, and so I don't forget. But I remember that name from the Mark Rober video. He's sitting on Mark Rober's couch, and he's like, I just had to give him, yeah, I did. I looked at his channel one time, and I don't know if I watched enough of his videos, but I love it because you can tell he got involved with coding young, and he's really skilled at it. And they built, how did they do it again? They did it with Python code, and if you look at it, it uses training data, holdout data, and uses validation data. Man, it'd be my dream if like someone like Mark Rohr or Jabril saw this right here and was like, yep. And I'd love for them to come and talk to us one day and be like, this is what we do, this is how we code, and this is what you can do awesome about it. But he's already making a ton of YouTube videos showing how amazing coding is, because in that video, if you pause the screen on it, and I wish I could show it, but you put YouTube videos on YouTube, you get in trouble. They'll be like, what are you doing taking my content? I mean, the content ID will catch it, so I don't want to show it on here right now. But if you pause that video, you can see he's got Python code on his screen, and you can literally see where it says like, I feel like playing it and finding that screen and showing you. But it's what we do in data mining. He's literally doing data mining techniques that we teach here at UT. So when I see these things, and Mark Rober's excellent use of statistics, I love it, and that's why I emailed them and was like, hey, can we use this data set? And they sent it to me because it wasn't originally linked on the video, and now they have it linked again, I think. But that's what was the original data from the first project, was a data set that they made that we did slight adjustment to make it more fun. Here's the saddest thing. A lot of times when you get data, you just don't get good results because real world problems are not very simple. But you can do things like Mark Rober does, where you figure out someone's baseball stealing signs by using coding, because it's just a code, and code can decode what a code is. So that was the perfect use of training data and validating and figuring out what the code is very quickly, because it can figure it out instantaneously. And it's so crazy, because I remember Mark Rober did a test with Jabrils, and he came back like a minute later, and Jabrils told him exactly what it was. The biases are confusing because sometimes one example can be multiple answers, if not detailed properly. Exactly. On the test, we will try to be as specific as possible, and I've told many people the homework on this one is good. The randomness homework is probably one of the best homeworks you can do to practice. The homework on this one is good. It's about the worst I'll say about a homework, is it's good. But the randomness homework is probably one of my favorites to practice for the test. Like, if you can do the randomness problems and understand how to treat it as a game, understand the rules of the game, that one you get really test ready for. And you just have to make sure you understand the concepts. You can't just memorize a homework question and be like, I'm going to ace this test. You have to be like, why does this work? Yeah. Good to see you here, Error. Sounds like Zelda 2, like I am Error. So we got good to see you here. But I think I got an award one time when I was a kid with the name Brain on it. So good to see you here. If you have a question, feel free to ask. We'll probably be wrapping up soon. But I love it that people are joining in. And it looks like, I'm trying to see I can't tell what your picture is. Yeah, Python. Do you have some experience with, if this was Jabrils right here, I would just, it's like I heard you talking about Python. It's anime. What anime is it? OFC. What is OFC again? I might know it when you say it, or maybe I don't know of it. Who is saying the sign stealing has been a crazy topic in baseball? Yeah. Did they do it? Yeah, Julio. We should put it in the chat here. Can't remember at the moment. Of course. Oh, that's OFC, of course. Julio, I'm gonna put this in the chat right here. And all right, so I can't play this, but this video has, or else we'll get content ID'd. But I'm putting this in the chat right now, Julio. It is a video that, so we should have it copied. And let's go over here to the chat. Oh, you're learning HTML? Oh, HTML is awesome. All right, cool. So there's the, I know, right? I'm in 9th grade and I can code in, whoa, C#, C++, Python, Lua, and Java. I think I've heard of that, Lua. Well, amazing job. Keep it up. You'll be on your way. If you want, we just put the video in the chat of the sign stealing, like making code to do that. The really great thing is the power of coding. Yeah, a lot of people are into that right now. Like, a lot of people, and that's really, the more you learn how to code, here we'll go to a blank screen in the background. The more you learn how to code, the better you get. So what it is employers nowadays are looking for people with skill sets. Someone one time told me that companies like Google and a lot of these Silicon Valley companies just say, well, what can you do? Show us your coding abilities, show us what you've done, here, code this, let's see what you can do. And by doing this, by getting experience coding Discord bots or things like that, you're learning how coding works. And we code in R. So here's what we code in right here. I was running some code earlier. This is some very basic code. Here, I'll show you another thing. I coded the Price is Right. Here's the Price is Right coded into R. So if I can see where my cursor's at. This is the Price is Right here coded into R. It plays the You can just play the Price is Right. So let's play this right here. We're going to play with the people in the chat. You ready? We got Error in the chat. We got, I don't know that coding language. What is that? It sounds vaguely familiar. There's so many coding language, but so many. I took in assembly class my sophomore year and made a voice activation like Alexa. That is so awesome. Yeah, sure. I don't know of this right here. Player one. Here, I'm going to play. Who else? Who wants to play Price is Right? Popular Roblox. Of course, Roblox. That's done in that language? I didn't know that. I'm learning something new right here. Thank you so much. Because as much as I know, which is not a lot, there's so many things. Spin the wheel. Adam, you're in the game. Error, you're old. Error, do you want to play the Price is Right? Do you want to play the Price is Right? We'll go right here. I'm going to quit it real quick, make sure the sounds are correct. Don't worry. Here, let's see. We got the sounds right here. We'll go to the... Okay, got them perfectly fine. How long did it take you to learn programming? It takes... the thing is, it's like... Imagine if someone asked you, how long did it take you to learn to play piano? It did it automatic. The autocomplete kicked in right there, so Julio's name kind of autocompletes on something. And so when someone says, how long did it take you to... Adam, you're going to spin the wheel. There's really no set amount of time it takes to learn to program. You just get better. And that's why if you look at someone like in Silicon Valley, I mean, I like to think I'm a decent programmer, but Adam spun in 85. What are you going to do now? Do you want to spin again? Yes or no? You can always get better at coding. And that's why starting early, it's like learning how to play piano when you're younger. If you learn how to play piano at a young age, you'll just get better. He's staying. Do we still have Julio in the chat? I'm going to spin for Julio. Julio, are you going to spin again? You got a 5. So, have you ever civil engineering grade? I have not. Nice job. That's, yeah. The earlier you learn it, he's going to spin again. 80, so close. So close right here. Now, I got to spin. It's going to be sad if I win. I didn't do this. I didn't cheat. I swear I'm not cheating. This is just, we all know what this is. This is all randomness. This is all complete randomness right here. This is just completely random. That's what we like to do right here. We like to talk about random. We just got randomness going on right here. This is oh, I gotta go soon here too. Just so you can see what's going on right here in the background, let's just take a quick look at the code. You know what I'm gonna do? I'm gonna spin again, and now I lost. Rigged. You guys get 10,000 points for playing. So I lost. I spun in 80. Want a fine class example of... Okay, I'll check that out. So Roblox. No, it's interesting. And I really like that people... Yeah, Julio, didn't we spin for you, Julio? Look at it. We spun for you. If you look at the code part that does it, this is where, if you notice, I'm making a data frame at the end right here. This is just a data frame. All these words right here that are printing to the screen, like, oh no, your final score, all this stuff right here. When you have to learn, when you have to study and where you have to learn to program. A really great site is, I think there's a Code Academy site, and I like Data Camp. So, oh, that's the code right there. That's the coding language. Game.players, local players, leaderboards, equals, and then the value here. So you're assigning a value, it looks like, to the people in the game board. Oh, wait. Oh, sorry. Eric, can you still post? Error, are you good? Post again. It got mad. Okay, good. We got Streamlabs on in case anything crazy happens. I've got the chat mod things on. I still saw it and I can still see it. Don't worry about that. You got timed out for 1 second. Don't worry about it. Just, we have Streamlabs on in the background in case, and I've got mods in the chat, as you can tell. Everything's fine. You're fine. I just saw all of a sudden blink away and I was like, what happens? And Streamlabs gets mad. So let's do an example. What do you want to see an example of? And I'll probably head off here in a moment. Team Treehouse Code. Yes, Adam, 10,000 points. Player 1 has 600 coins. Okay. So player 1 was 600 coins. So I'm looking at game players, local players, leaderboards, values go here, value. So it looks like it's assigning, we're going to take it as a player 1 using the script. Okay. So the player 1's game players, so that's, okay. You're going to be, if you're doing this early on, you're going to be way ahead of the game. So we do not have to identify player 1. Okay, so they're kind of stored So wait, player 1 has 600 coins. So yeah, I can kind of do it in code in the background here. I'll do it in R. We can just identify player 1 as a local player. Okay, so you're saying, what we do right here, I'll show you what it looks like in coding language here. I'll kind of write what you're writing, at least how I'm seeing it. Players, can't spell players. I'll learn how to spell one of these days. So we're going to go right here. We're going to go player 1, player 2, player 3. This is what we call a vector storing into an object. Thanks for answering my questions. You're welcome. Yeah, awesome. One of these days I might make Python videos. I've only coded the smallest of bits in Python. I code a lot in R, but you learn one programming language. I'm sure Era will tell us you learn more. It becomes easier to learn programming languages as you keep learning them. So keep it up. Like, start looking into that. I'm so glad Adam put some stuff in the chat too. Have some fun shooting some hoop. We'll have M&Ms tomorrow. And so what I'm gonna do here is I'm gonna call local players, and we're just gonna call local player. We're gonna go to the list of players, and we're gonna call element number 1. So I'm gonna show over here what's going on with the code in the kind of brain of R. So if you look at what's going on right here, this just stores players right there, and then the local player is stored as player 1. Is that kind of, so you want to change the value of player 1's coins. So actually I might need to make local player a list. Let's see, I can make local player, I want to make it a list now. So player 1 has coins. What I want to actually do, watch this. So here's what we're going to do. We're going to do coins. And we're going to store coins as though no one has coins. I'll look at chat in a second. These NA values stand for nothing. So if you notice, that's a vector with nothing inside of it, if you see what I created up there. And now what I'm going to do is I'm going to take and make this into a data frame right here. So a data frame just looks like an Excel spreadsheet. So I'm just going to call it df for data frame. And we're going to put players right here. And we're going to put coins. And now we look at our thing that we just created. Sorry, I lose my mouse all the time on this computer. Here is what we created. Oh my gosh, where is it? There it is. Here's what we created right here, and now we could go in and change the value of the coins. Is there any way I can actually speak? No, just type in the chat right there. Yeah, no, this is what kind of I'm seeing what you're saying right here. Like a list. We can make lists inside of this. I so rarely use lists. If you do a list right here, you can make a list of an object. So we could go right here. We've got the players in the list. We've got the coins in the list. And so I use data frames more often. It's just kind of what we do more often. And now the list has those objects. And so we could call this like local data. So local data is a list of those objects. And then if you see, if we go inside local data, we can pull out just the player names right there, or we could pull out the assignment of the coins. And we should be able to assign coins to player 1. If this is done proper now, we should get player 1 having 30 coins. Yeah, no, there's so many things right here. This is kind of what I'm hearing you saying, and this is how we would do it using kind of lists or data frames. If you notice, I've got the list right there, and I've assigned 30 coins to player 1. So that's just calling the action because this double brackets is used to go inside of the elements. Does that kind of make sense what I'm doing with our coding language? But if you learn Python, if you learn HTML, if you learn XML, C#, C++, you're doing an amazing job, and keep up the amazing work because really proud of you. Learning coding is a great skill, helps you learn to think logically and all that stuff. Yeah, well, keep up the awesome work, and always feel free to ask those questions. I'm going to head off, but we're going to play our outro real quick again. So good seeing you, and have a great evening. See you later.
Like TV from other dimensions has a somewhat looser feel to it.
Yeah, it's got an almost improvisational tone.